objective. And our objective in this particular example is to find the angle theta right over here. That's our target, our mission. Now, in order for us to zero in on that, we need to be able to find some surrounding data and information. What data do we find? Well, that depends on what data they've given us. Let's take a closer look at what they've given us in these two triangles that seem to be stuck together. It's a giant right-angled triangle, and they've only given us distances. We have here the height, 8.5 meters. That's the length there. Across here, we have 10.2 meters, and the length across from here to here is 7 meters. Notice they've given us no angles inside, and we are asked to find an angle. Now, since we're going to focus on our target, our outcome, our objective, which is theta, that means we're going to need to find other angles also. So how do we find these other amazing angles? Well, what do we have? Well, because we've got these lengths, we can use the theta or the angles in here to work out the angle up there. So the first step is to find the internal angles of these two triangles, and then we can work our way up to this angle theta. Now, the way to work up there is to recognize if we can kind of get three angles up here and this kind of triangle out here, because of angle sum of triangle, and I love that, that's amazing. Angle sum of triangle, where we have two angles, bang and bang, we can work out the third angle easily and effortlessly. But the objective is to find these angles first. So let's have a look at what angles we can find easily first. The first one I suggest we find is this one right in here. Why? Why do we need to find that? Well, because if we find this, we can get the supplementary of it, which is on the other side. See that right over there? And if we get the supplementary, and we can work out this angle, given the adjacent and the opposite here, then we'll have two angles. Those two angles will be angle sum of triangle, as I said earlier, and that'll give us this final angle theta. So let me walk you through it now. Let's start off with step number one, and that is to find the angle in here. So what are we going to call it? Let's give it a name. Let's call it angle alpha. All right, there's our angle alpha. There we go. Let's find angle alpha. So this is the way to do it. It's going to be opposite, as you can see here, over adjacent, right? Right next to it is that length there. So opposite of adjacent is tan. So let's do that. So let's go tan alpha. Let's fix that up. Tan alpha equals opposite, which is 8.5, over adjacent, which is 10.2. Okay, tan alpha, 8.5, 10.2. Let's put that in the calculator. 8.5 divided by 10.2 will give us a decimal. Then you go shift tan, and then shift degrees, minutes, seconds. So you get it in degrees and minutes. So in this particular example, we will get alpha equals, once we've gone through that process, alpha equals 39 degrees and 48 minutes. Okay, did you get that? I'll repeat it. What you do is you go 8.5 divided by 10.2, that'll give you a decimal. Then you go shift 10, that'll give you a decimal degree. And then you go shift DMS, or degrees, minutes, seconds, and it will give you degrees and minutes and very few seconds. So we rounded it up here, yeah? So let's write that down here next to the alpha. Can we do that? So this angle here will be 39 degrees and 48 minutes. Okay, cool, we got that angle. Now, the next angle I want to get is this angle in here. So that's going to be supplementary, isn't it? Which is easy to find because it's a straight line and you've got a line cutting through it. And if you remember your geometry, supplementary on the inside. So what are we going to call that angle? Let's call it another Greek letter. Let's call it gamma. Let's call it gamma. Let me just put the gamma in here. There we go. There's our gamma. Now, gamma is going to be supplementary to that. So let's work that out and go 180, which is the straight line, take away gamma, take away alpha actually, take away alpha is going to give us the angle gamma, isn't it? So let's write that down again. Let's double check, let's point it out. 180, straight line, take away alpha, which is that angle there, is going to leave us that angle gamma there. There's gamma there. Can you see that? All right, let's actually work that out. That's going to be, that's 39 degrees, 48 minutes. And 48 minutes. Let's subtract them, put them in the calculator, and it will give us a final result of gamma equals 180. Take away 39 DMS, 48 DMS. That's going to give us a grand total of 140 degrees and 12 minutes. Okay, there we go. Let me just put a red line under there. That's that angle right in there. And let's write it in actually. That's 140 degrees and 12 minutes. Great. We have those two angles there. Now we need to work this angle out, and if you remember, we have the total length across here, which is adjacent, and we have the opposite right up there, which is the 8.5. Let's do that now. So that's going to be a tan, obviously, opposite over adjacent, as you're well aware. So let's write down now tan, and that's going to, what angle should we call it? Let's call it beta. Let's call it beta. Let's put it in there. So angle beta is going to be right there. Angle beta will be, that equals, well, opposite, which is 8.5, and adjacent is actually that length plus that length together. So that's 7 plus 10.2. Together they add up to 17.2. So let's put that in. So that's going to be over 17.2, and that's the adjacent down the bottom. And opposite right in front, of course, is the 8.5. Let's put that in. 0.5. Okay, let's put that in the calculator. 8.5 divided by 17.2. That'll give us a decimal. Then you go shift tan. Once you do shift tan, that'll give you a decimal degree. And then you go shift degrees, minutes, seconds. It'll give you degrees and minutes and seconds. So that'll give us a final answer for beta. So beta will equal, once you've put that into the calculator, beta will be 26 degrees and 17 minutes 53 seconds. Now we can round that up, can't we? 17 minutes 53 seconds. 53 is above 30. So that means this 17 goes up, doesn't it? We round it up. Therefore, beta will be 26 degrees 18 minutes. It went up, yeah? So there's our beta right there. There's our beta, there's our gamma, and here's our alpha. All right, what we really need now is the angle, these two angles here, because we've got gamma, we've got beta. That'll give us theta because of angle sum of triangle. That's an amazing equation, that one. So let's just write this in before we do that. We got beta there, so let's write it in. It's always good to label our triangles. So that angle there is 26 degrees and 18 minutes. Terrific. Let's do the angle sum of triangle. That plus that will give us 180. Let's write that equation. So that's going to be, okay, angle theta plus beta plus gamma equals 180 degrees. Let's point that out. Let's make sure we got that right. So we have theta right up here, bang, plus beta right over here, bang, plus gamma right over here, bang. All those three angles add up to 180 because the angle sum of triangles is 180 degrees. Good to know that. Okay, we want to make theta the subject, so let me make that singular and make it by itself like that. So that's what we're going for. Let's take the beta and the gamma over to the other side of the equation. So we subtract both sides by that. So that's going to give us a theta. Theta is finally going to equals 180. Now we're taking away beta and gamma from both sides. So that's going to be minus beta minus gamma. Okay, good. So that's how we're going to find theta. So let's actually put the numbers in there. So theta equals 180 take away. Now what's beta again? Beta is 2618. Let's write that in. 26 degrees 18 minutes. Minus again gamma, which is 140. Minus 140 degrees and 12 minutes. Okay, 180 minus 2618 minus another 140 and 12 minutes. That's going to give us the grand total right over here for theta. There's our theta, and that's the angle right up here, this tiny angle. It's going to be a small angle. Put that in the calculator, 180 minus 2618, 140, 12. That's going to give us a grand total of theta equals the little theta up there, 13 degrees and 30 minutes.